This is AI-909 by Taylor Peer, and I'll mention again, Taylor works for Cortical I/O, so this is ineligible for prizes, but it's still a cool application. Go ahead.
This is the AI-909. It's a drum machine app that I created over the past couple of weekends for the Numenta HTM Challenge. It has 3 channels for a kick drum, snare, and hi-hat. And it runs as a web application, so it works on a computer, tablet, or most devices that have a browser. You can program a drum beat on it by turning the drum steps on and off, so like this. Playback and tempo controls are here. But what makes this different from other drum machines is that it can learn patterns and generate new ones by using the HTM's ability to predict sequences. So the user has 2 buttons to interact with the HTM, learn and generate. By learning a pattern, it saves it to the current memory location, and when the user presses the generate button, a subsample of the learned patterns in the current memory location are used to train the HTM and output a new predicted pattern. And by changing memory locations, the user can store different kinds of training sequences separately. So you could train the HTM to compose different kinds of musical styles in different memory locations and then switch back and forth between them. So I'll go ahead and let it learn the current beats. Once I do that, I see the sequence displayed in the bottom part of the screen. So far this is the only sequence it knows in this memory location. And since it won't be able to generate anything interesting with just one training example, I'll teach it a few other beats. And so now that there's a bunch of examples to learn from, I can start generating new sequences with it. And so the way this works internally is pretty simple. The 3 drum channels get encoded together into a single numerical sequence. So silence on a beat is represented by the number 0, I think a hi-hat is a 1, a kick and a hi-hat together are a 5, and so on. And then those integer representations just get put through a scalar encoder, and from there the HTM learns the patterns using the spatial and temporal poolers. So to generate a new pattern, it just predicts step by step the next integer value in a sequence, and then that predicted value gets fed back into the HTM as input until it's predicted an entire 16-step drum beat. And so even with just 3 channels, the AI-909 is able to come up with some interesting and varied compositions, and I think it's easy to imagine how this could be expanded upon. First of all, by adding more drum channels, or eventually also applying the same concepts to tonal music to use the HTM to write entire compositions. And all the code I wrote for this is on GitHub, so feel free to take a look at it, make improvements, build upon it, whatever you want to do. The backend is all in Java, so I'd like to thank my coworker David Ray for his contributions to the Java port of the HTM, as well as everyone else in the NuPick community.
Taylor, you can come up to the mic and take questions from the panel. Let me just say that I'm going to put this on my kid's iPad because they would really like this. So.
You have to have it running on a computer, though, in the background. So.
Oh, dang it. One of these days, right? Okay, open up to comments.
Taylor, it's a lot of fun. I asked you a question online about this, but I'll ask you a similar one here, too. I'm just trying to understand how much HTM is adding. And so one way you could ask that question is like, did you use the memory function to say, okay, I'm going to give some nice slow things on one grouping and another? You know, they really sort of show 2 different classes of rhythms, and then see if the HTM generalizes in those 2 different classes that you could tell. I'm just trying to understand, how do you know how much the HTM is doing? And one way would have been to do like 2 types of patterns in the 2 different memory functions, if I understood it correctly. Did you try that?
Yeah, exactly. I did try that myself. I didn't show it in the video, but yeah, it does learn the differences when you train it with like one style of music in one memory location and then switch to another one. It does output different kinds of beats.
Yeah, and then the second question was, could I tell the difference between this and a monkey doing it? I mean, it's just like, you know, they all sound good to me, so I'm not sure if that's just your talent in the HTM, or if some ignoramus like I did, it would work okay too, you know?
Yeah, evaluation is kind of a difficult thing here. I just played around with it till I thought it sounded cool. That was it.
Are there patterns that don't sound cool?
Yes, it is able to output gibberish too. That did happen in the beginning.
Oh, okay. All right, good. Very nice. Well, it makes it take them 3 months to learn if you want good output, if they just like bang out something. I have no idea how to evaluate the performance. You know?
Yeah, I think that's a general problem with algorithmic composition.
Yeah.
How do you know if it's
but one way is by using those multiple memory types, and you can at least see if it's catching, if it's at least learning and getting things that are similar to the things that it's been trained on.
Yeah, exactly. Yeah.
So one way to evaluate is to play it at a rave and see how long people dance.
So can you explain, when you trained it, you had a series of sequences that was used to train. So what was it that was similar among those sequences? You said they had a certain style. Was it the beat or what?
Oh, yeah. Well, to me, they were all like kind of drum and bass breakbeat sequences that I trained it with. So, yeah, they're all stylistically similar.
So this is really cool and very slick presentation, and I want to play with it. But I think I'm missing something at the heart of the generate function. And I'm wondering if you could slow it down for me, step by step, what's exactly going on there. I think what's happening is that you are creating these sequences, and then the HTM is learning them. And then when you press generate, it's going through them and then asking for what would the next thing be. And that's the prediction.
The next step. So it generates the first beats randomly, or not randomly, but it takes the most probable one from the training sequences. And then it says, okay, it asks the HTM, what's next in the sequence?
But it's not looping the sequence, because then it would learn it perfectly and it would just think that the first one.
Yeah, I think the question is, I had the same question you answered online, is what prevents it from just playing back what it learned earlier?
But it's not, because it's not a loop. It's left. You fed in this example four sequences that are concatenated then, or?
Yeah, exactly.
So they're concatenated together.
And then, it
gets to the
resets.
end.
It resets after each one, but yeah.
Oh, okay. And then at the end you're saying what's next, but it doesn't know what's next, so it's going to make its best guess based on.
Yeah, basically.
Okay.
I didn't explain in the video. I explained it to Jeff in an answer online. It trains it every time you press generate. It trains it on a different subsample of the training. Training sequences. So that's why it outputs something different every time. Because otherwise it would just learn like the average beats over all of them, and that would be kind of boring to just generate one thing and then never get anything
So
new out of it
it's
again.
an abstraction. In theory, it would be the style, like you said.
Yeah, basically you give it a bunch of sequences, and then when you generate, it takes a random subsampling of those, trains the HTM on that, and then it uses that to predict a new one.
Right, so it'd be interesting if you had one that had a lot more channels and you fit in like a Bach fugue. At the end of that, what would it?
Yeah, that would be a little bit more complex than this.
But in theory, that would be an interesting experiment, no?
Yeah. Maybe at the next hackathon.
So in some sense, is it taking an interpolation or an averaging of the training samples?
Yeah, I'm sure internally that's basically what it's doing. It's learning like kind of sub-patterns, or what beats follow other beats.
So the inputs you encoded as numeric values from 1 through 7, whatever, 0 through 7.
Yeah, exactly.
How did you constrain the output? How did the HTM know not to generate 15 or something as an output, and how did you interpret that?
Oh, I thought that was kind of inherent in the way
It's never seen 15 before.
Yeah, exactly. So I thought that.
Even though he says they're numbers, it's really treating them like categories.
Okay.
Yeah,
categories.
exactly.
They're really just
They're not
categories.
values. Okay.
Yeah.
Okay.
It's kind of misleading to say, oh, it's a 7. It's like, nah, it's just
Right.
something.
One thing I was confused about was the memory locations. How did that tie to HTMs? What was the mapping between memory locations?
Oh, well, that's separate. That has nothing to do with the HTM.
Okay,
That just when you train, you give it example sequences. They're stored in a memory location. So that's why you could train it to do other kinds of beats by storing them in another memory location. So it's not HTM memory. It's
Okay.
Is there only one model then running? And
yeah, exactly.
So you could train a model on one style and then another style, and potentially you could create a combination of styles. Right?
Yeah, true. You could do that too. Yeah.
Cool.
I'd love to see it with I think someone did some work with MIDI once. We really love to see it, not just the rhythm, but also a melody as well, and then and to see then you'd really have a better sense of how creative if it's how good it is. But That'd be a nice extension.
Yeah, this was actually the first application I ever made with the HTM. So over the time working on this, I realized other people have been doing audio too. So yeah, it'd be interesting to put this together with people working on tonal music and then.
Because it's a great interface. I mean, I would love, it's fun to play with, right? So it'd be a great way of experimenting with like, oh, well, if I teach it this sequence and this sequence and this sequence and then put that in one memory, how well does it generalize like that? I mean, you would get a better sense, at least I would get a better sense of some of its attributes, but it's a nice interface for doing that, so.
Very cool.
Cute.
Thank you, Taylor. Very good.